Now, practically, one more laser is in syllabus, and that is semiconductor laser. Semiconductor laser. The semiconductor laser, as its name, that active medium will be semiconductor. Active medium will be semiconductor, and generally semiconductors are silicon, germanium, gallium, arsenic. These are the semiconductors. So here the semiconductor laser is more appropriate to call semiconductor laser diode. So obviously it is a diode. We have various type of diode. That the simplest diode is PN junction diode, and the symbolical representation is this. It is P and it is N. Now we have various type of diode. So first, that simple PN junction diode, and we can make the diagram like this, that it is the symbolical representation of PN junction diode. Now one more diode, that is Zener diode. The symbolical representation of Zener diode is of this type. As already we know that in Zener diode, at a particular voltage, the current is maximum and it can work as switch. That at a particular voltage, the current will flow start and it will work as a switch. The third, photodiode. Fourth is the photodiode. In photodiode, the symbolical representation is this, or it is known as photocell also, we can say. Photocell. What happens in this? That if light falls on this diode, then working will start. Working means the flow of current will take place. And one more type of diode, that is LED, light emitting diode. In light emitting diode, what happens? That if we start current flow in this, then an emission of light takes place. That is emission of light. In previous one, photodiode, what happens? When light falls on the diode, current will start. And in this LED, when current passes, light is produced. So the process of laser diode and semiconductor diode, this LED, is same. That in both the diodes, even in semiconductor laser diode and in LED, laser light emitting diode, both produces light. So simply we will discuss that how PN junction works. So it is PN. If we connect in forward bias, then the positive will be connected with P, and similarly we can connect it in reverse bias. When the positive of the battery is connected with N type and negative of the battery is connected with P type semiconductor. It is the forward bias, and if we make the plot, the diagram, then this type of diagram we can have forward bias and reverse bias characteristics. Up to few volts, for few millivolts, we can say the current is not there, and we can say this is the voltage which is equal to the depletion region. As we know that when we connect PN junction diode, a depletion region is formed where the charge carriers are not there, because the sum of the P type and sum of the N type carrier neutralize each other, and ion free region is produced, that is known as depletion region. So what happens in forward bias? Suppose if I connect in forward bias this diode, that if positive ions starts from here, then it will reach at P type semiconductor where already the positive ions are in majority, and if negative ion starts from here, then it means electron, and already in N type semiconductor electrons are there, so they will repel each other and the carriers will cross the barrier and a current flow will start, and there will be no depletion region as such. But when the electrons and holes they will meet, then they will neutralize each other, and a generally heat will be produced. That's why we say that when semiconductors are working, a heat is produced, and this heat is basically the recombination of holes and electrons. This heat is due to recombination of holes and electrons. Now, if somehow this recombination of holes and electron, if it converts into heat, then as a normal diode is there, and this is converted into light, then it works as LED or the laser diode. So basically, this laser diode normally we made with gallium arsenide, and a systematic diagram of laser is this laser diode, that it is a p region and it is n region. This is the electrical with this heat sink and electrical contact. This is roughened surface. This is metallized electrical contact, and this side we can have the laser. So here in this laser, the semiconductor laser, basically when holes and electrons are meeting or then recombination, then a light will be produced. So a typical semiconductor laser is of this construction of semiconductor laser is this, and it is the active medium which is in this region. This is the active region. Now there are various characteristics of this laser light, that it is highly directionality, monochromaticity, coherence, highly intense, and many more that already we have discussed. So this is about the semiconductor laser.